I'm going to talk through something called diode bridge rectification, which is a rather complex term. Basically, it means that we want to go from an alternating current in this simple circuit where we just have a resistor connected in series with an AC source to a current which is only positive, because here we're going from positive to negative, and that can have some negative effects sometimes. So we just want to have this is a direct current. We want to go from AC to DC, basically, where the current goes in both directions to where the current only flows in one direction. And we use that using something called a diode bridge. So let's start off by rectifying our wave only by half, and we do that by, here's our AC source, here's a wire, we plug in series something called a diode, then we have our resistor, and we're measuring the voltage across the resistor, by the way, and then we connect up to the AC source in. What the diode does is it only lets current flow in the direction of the arrow. So in this case, we'd go from this voltage time curve to a voltage time curve which only shows the positive parts of the curve. This is what we call half wave rectification. And I'm going to get you to build this in a little simulation, or you can build this in the simulation. However, to go for the full wave rectification, we have to put in what's called a diode bridge. So let's start with our AC source. Change it to black. We have our AC source. Then we come down here. Now, instead of having just one diode, we're going to use 4 diodes. So when the current flows in this direction, I'm going to have one diode pointing in this way, linked up here, with a resistor across here in a bridge. Then I'm going to come to another junction. I'm going to put another diode pointing in this direction, ending up down here, and then we're going to complete the circuit. So when the current flows clockwise, the current flows this way, and then it flows to the left through the resistor, and then through this diode, and then onwards. However, when the current flips, going in the anti-clockwise direction, comes through here, but then it can't flow through this diode. We have to plug in another diode here, join it up here. What happens is the current flows through here, and then it can't flow through this diode, it has to flow through this way. So it ends up flowing through the same way through the resistor to the left. But then we need another diode here to allow it to flow and complete the circuit. So this is what we call a diode bridge, and you end up seeing the full wave rectification, but it does actually go down to 0 at certain points, and the way you overcome that is by using something called a capacitor connected in parallel to the resistor, and the concept of capacitance we're going to come on to in a later stage. But basically, to either end of these junctions, you take wires away and you join in something called a capacitor, which is a store of charge. The effect of adding the capacitor basically smooths out the full wave rectification, so it doesn't go down to 0. It basically goes down a little bit and then goes back to the maximum again. So this is a smoothed full wave rectification. Rectify means to correct, so basically we're correcting for the alternating current to go to DC current. And I'll provide a link in the comments to a simulation on Faldstad's website where you can actually make your own rectification circuits online in these corona times.